Hello, I'm going to review the first problem on the D2L quiz. We have the inverse demand given by 78 minus 15Q. This is a profit maximization type problem, so we're going to get marginal revenue. Recognizing that marginal revenue has twice the slope of the inverse demand, marginal revenue simplifies to this. Because we can produce output in two plants, I am going to substitute out capital Q for Q subscript 1 plus Q subscript 2. I will simplify that. And then I'm going to set this marginal revenue equal to marginal cost. And let's set it equal to the marginal cost of plant 1, which we see over here is 3 times output. And we get the following result. The next thing we'll do is we'll add up our Q terms. Q subscript 1 terms, that is. And we get the following result. Okay, next just dividing here by 33. Both sides of the equation by 33. Get 78 divided by 33. And the following. Okay. So this is the output that will be produced in plant 1. Alright, we're going to do basically the same thing, but this time we're going to set marginal revenue equal to the marginal cost of plant 2. Alright, let me move this down. Yeah, let me get just a clean screen here maybe. Yeah, let me go right here. Alright, so marginal revenue equals the marginal cost in plant 2. Same marginal revenue equation. But this time marginal cost in plant 2 is given by 2 times the output in plant 2. This time let's solve this equation for Q subscript 2. And get that, and dividing through by 32. We get that result. So we got this equation over here and this equation over here. Two equations, two unknowns. We'll substitute one into the other to solve the output. So let me go on over here and clear the screen. Okay, so the output in plant 1, let me go up. There we go. The output in plant 1 we said equaled the following. All I'm going to do is plug the output into the output from plant 2, that Q2 equation, into here, and we'll get the following. Again, this part in parentheses is coming from that Q subscript 2 equation, which equaled the stuff that's right here. Simplifying this mess, we're going to get something that looks like this. I'm going to put everything on common denominators here. It'd probably be easier just if you worked with decimals here instead of these fractions, but that's what I did here anyhow. Okay, this next step here will simplify down to the following result. Just subtracting 900 divided by 1056 from both sides leaves us with this. And this is nice because output in plant 1 just equals 1 unit. Okay, so all of that mess just simplifies down to 1. Next thing we'll do is just take this output in plant 1 and plug it into the Q subscript 2 function. So let me do that. So the output in plant 2 was given by this equation here. Oops. That's going to be a 2, sorry. And just plugging 1 in for the output in plant 1. The output in plant 2 is 1.5 units. Okay, we're almost done. Next thing we need to do is just evaluate the firm's inverse demand equation at 2.5 units of output. 1 plus 1.5. Clear the screen. Inverse demand. Evaluated at 2.5 units of output gives us the answer we were looking for, $40.50. So that's how you do problem number 1. Okay, let's solve problem number 2. Here you're a manager of Monopoly that faces a demand curve described by P equals 230 minus 20 times Q. We get marginal revenue. And we'll set marginal revenue equal to marginal cost. Let's see, total cost is 5 plus 30Q. And marginal cost then is just constant $30. So we get 40Q equals 200. This firm wants to produce 5 units of output in order to maximize profits. Number 3 is another multiple plant problem. First thing we'll do is get marginal revenue. Next, we will substitute each plant's output in for Q. Simplify it. Whoops. And we get that expression. Next, setting marginal revenue equal to marginal cost in plant 1. And we will set that equal to, let's see, 2Q subscript 1. simplifying for Q1. We get the following result. We got to basically do the same thing, but this time for the second plant, setting marginal revenue equal to the marginal cost of the second plant. We will get the following. Solving for Q subscript 2. And now dividing by 16. That expression will simplify down to something like that. Alright, the next thing I'll do is I'll take this part of this equation right here and I'll substitute it into the output equation for plant 1. Plant 1's output then will equal 120 divided by 14 minus 12 divided by 14 times 7.5 minus 3/4 the output of plant 1. Okay, so multiplying what's in parentheses here by minus 12 divided by 14, we get these results. Simplifying this up a little bit, and then solving. We get the answer of 6. Okay, so 6 units of output will be produced in plant 1. Okay, on to question 4. Standard monopoly profit maximization problem. Rewriting the inverse demand. Solving for marginal revenue. To maximize profits, we set marginal revenue equal to marginal cost. We need marginal cost though. We got a cost equation, total cost equation of 10 plus 3Q. Taking the derivative of that, we get marginal cost equal to just $3. Then setting our profit maximizing condition up. Profit maximizing output is 6. Profit maximizing price. Taking the 6 and plugging it into the inverse demand, 63 minus 30 or $33 is the profit maximizing price. In this question, however, we want to find what is the maximum profit possible. We build our profit equation. Total revenue, 33 times 6. To subtract out our total costs of 10 plus 3 times our output, which is 6. And so this will simplify down to $170. $170. Alright, that is problem 4. Okay, moving to problem 10, next quantitative type question. Here we have a price discrimination type problem. Monopolist faces two markets, different demand conditions, but in problem 10 we're going to assume that the monopolist will not price discriminate, and that is charge everyone the same price. First thing we need to do is get the total market demand. Total market demand, Q, will be the summation of the market demand from market 1 and market 2. So just getting these demands from the question, simplifying. And we get that result. We can ignore the subscripts. When the firm is not going to price discriminate, the price will be the same in market 1 and market 2, so we just add up the P terms. What I'll do next is get the inverse demand. Okay, and dividing through by 0.5. We get that result. Marginal revenue. It'll look like that. Okay, before we set marginal revenue equal to marginal cost, let's just solve for marginal cost. Going to take the derivative of the total cost equation over here, just as 10. So 4Q equals 132, and this means that Q equals 33. So that's the profit maximizing output, but we're asked to find the profit maximizing price. So we're going to take this 33 and plug it back into the firm's inverse demand equation. Okay, plugging this back in the firm's inverse demand equation, we get a profit maximizing price of $76. Alright, that's problem 10. Okay, the final quantitative problem from the D2L quiz is basically based on the previous problem, problem 10. Here again we have a firm that's facing two markets, and this time the firm is going to price discriminate, and we are asked to find the profit maximizing price for just market 1. So just analyzing market 1. Market 1 has demand conditions given by the following. Solving for the inverse demand. Here I just divided through by 0.1. We get the following result. And then marginal revenue, oops, this is for market 1. Marginal revenue in market 1 will be 210 minus 20 times Q subscript 1, setting marginal revenue equal to marginal cost. Marginal cost is, well, the derivative of the total cost equation, which we did in problem 10. We found that was just equal to 10. And this firm wants to produce 10 units of output for market 1 in order to maximize profits. We're going to plug this 10 into market 1's inverse demand, and we get a profit maximizing price of $110. $110. Okay, hope that helped. Thanks.